So I'm going to go ahead and talk you through some strategies for problem solving. And in this video, I'm going to go through a bunch of examples similar to the ones that you'll have in your homework. At certain points throughout this video, I'll pause, see if you can answer the question, and then we'll keep going so you'll have a pretty good understanding once you get to your homework. Specifically, the essential question that we're going to go through in 1.3 is reviewing Polya's four-step approach to problem solving. So we're going to go over different strategies that you can use to solve problems, and the way we'll practice those strategies is by actually solving some problems. So when you teach problem solving to your students at the elementary school, these are the 4 steps that you'll constantly go over with them. The first step is just to understand the problem. You're going to need to read the problem a couple of different times, so that's important. You'll need to come up with a plan, and then you'll have to carry out the plan. And the key here is to be persistent, even if you reach a dead end. So you may do something, not get the answer, you'll go back, and you'll devise another plan. And then the last step is to make sure that you look back and check your answer. Probably the most common thing that folks do when they are problem solving is use the strategy of trial and error or guess and check. So most of you use these strategies when you solve problems, and that's okay. So I don't want you to feel discouraged if that's the strategy you try to use. But other strategies that I want you to be aware of is drawing a sketch, considering a simpler problem. So we did that even last week when we were looking at the Gauss problem. Rather than counting from 1 to 100, we did from 1 to 10. And that's okay for you to do even in your homework. Make it simpler, then come back and revisit the tougher problem. Use common sense. And sometimes you might need to use some estimation. You might want to round first and make the problem simpler that way, and then go back and solve it again. So let's look at one of your homework problems. It says balls numbered 1 through 6 are arranged in a difference triangle so that in any row, the difference between the larger and the smaller of the 2 successive balls is the number of the ball that appears below them. So what I want you to do is just look here on the bottom. I know that C minus D has to equal 3, so I'm just going to use some trial and error here. So if I've got 4A and B, I need the difference between the 2 numbers where C and D are to be 3. It can't be a 6 and a 3 because I've already used 3. But maybe I can make it a 5 and a 2. Well, that's not going to work because I can't subtract something from 4 and get 5. So let's try 2 and 5. So if I put 2 here and 5, the difference between them is 3. So that'll work. And then if I look above now here, well, I need the difference between 4 and a number to be 2. Can't be 2 because I've already used it. So let's make this guy a 6. 6 minus 4 will give me 2. So I've now used 2, 5, 6, 4, and 3, which leaves the only one that I can use a 1. Does that work? 6 minus 1 does give me 5. And I just had to play around with it a little bit. So C is going to be 2. D is going to be 5. A is going to be 6, and B is going to be 1. Let's look at another problem. It says use inductive reasoning to determine the units digit of the number 3 to the 42nd power. So in this problem, you're going to have a couple of them like this in homework. What they want you to notice is that there's a pattern. 3, 9, 7, 1. 3, 9, 7, 1. Let's write that pattern out. So without even thinking, what would 3 to the 13th power end in? 3, 9, 7, 1. This one's going to have to end in a what? I want you to put that answer in. You should have put in a 3 because that pattern's going to continue. So how can that pattern help us figure out 3 to the 42nd power? Well, all my multiples of 4, 8, 12, they all end in 1. So let's think, what's the closest multiple of 4 to 42? You've got really two choices. You could either go with 40 or you could go with 44. So if we keep working the power out now, the 40th number we know is going to end in a 1 because it's a multiple of 4, which means the 41st is going to be your 3. The 42nd is going to be your 9. And then if we continued, the 43rd would be your 7, and we're back to the 1 on 44. I want you to give it a try. Rather than 3 to the 42nd power, can you figure out what 3 to the 81st power would end in? So we've got a mail package that requires $1.38 in postage, and we only have 5-cent stamps, and 9-cent stamps. And we want to know the smallest number of stamps that we could use to total exactly $1.38. So if I want to minimize the number of stamps I'm going to use, I want to maximize the number of 9-cent stamps that I can use. So let's suppose that I only use 9-cent stamps. How many 9-cent stamps would I need to get as close to $1.38 as possible? 15 9-cent stamps gets me as close to $1.38 as possible. In fact, if I multiply 15 times 9 cents, that gets me to $1.35. So I still need another 3 cents in postage, but I don't have 3-cent stamps. I only have 5-cent stamps. But what I can do now is decrease from 15 and start to make a table to figure out the number of stamps that I need. So you can see that I've made a table. If I had 15 9-cent stamps that would get me all the way to $1.35, I still need 3 cents. It's not divisible by 5. So let's try 14 9-cent stamps. So 14 9-cent stamps is going to get me to $1.26. And I'm now 12 cents away, and that's still not divisible by 5. So let's try one less. Let's try 13 9-cent stamps. That's $1.17, and I'm 21 cents away. I'm going to keep doing this until my remainder is actually divisible by 5 cents. When I take it down one more to 12 9-cent stamps, that's $1.08, and that is 30 cents away from $1.38, and 30 cents is divisible by 5, so that means that there would be 12 9-cent stamps. How many of the 5-cent stamps will we need? Here's another homework problem. A salesperson receives a weekly salary of $350. So $350 per week. $30 is paid for every item sold in excess of 200 items. So $30 for every item sold over 200. How much extra is received from the sale of 218 items? And then it says which piece of information is not necessary to solve the problem. So in this particular problem, if we're just looking at how much extra is received, think about that. If I have 218 items, that's 18 over 200. So I needed that 200, and then I could take that 18 and multiply it by the 30, and then that would give me my answer. So which of these wasn't used? Well, I see that I used the 200. I see that I needed the number of items sold. Oh, did I ever use that 350? Nope, it doesn't look like it. So that seems to be what is in excess. I want you to try this problem on your own. Calculators were purchased at $80 per dozen and then sold at $25 for every 3 calculators. So we want to know the profit on 6 dozen calculators. So I got to figure out how much did those 6 dozen calculators cost me to buy. So at $80 per dozen, if I've got 6 of them, it costs me $480 to buy them. Now what I want you to figure out is how much you sold them for. How many groups of 3 are there on 6 dozen calculators? There are actually 24 groups of 3 when you've got 6 dozen calculators. So we can take that 24 and multiply it by 25 because we're making 25 on every group of 3. So we actually made $600, but remember we had to pay $480. So what's our profit? We have 5 runners. We've got Andy, Beth, Dale, Ella, and Try. We know that Ella finished 3 seconds before Beth. So we know Ella is before Beth. Beth finished 7 seconds after Try. So Beth, 7 seconds after Try. Try finished 6 seconds after Dale. Try, 6 seconds after D. And Dale finished 4 seconds before Andy. I'm going to just really do some guess and check with this one and play around with it a little bit. So let's put these in order just up at the top based on what we have. We know that the E has to be before the B. We know that the B has to come after the T. We know the T has to come after the D. And we know that the D has to happen before the A. You really have to pay attention to the times though, because this here doesn't really tell me what happens in the middle. So let's put these guys on a timeline. I'm going to put Ella, because she's mentioned first. I'm going to put her at time 0. Okay, so we've got E at time 0. We know that B was 7 seconds, in E is 3 seconds before B. So if E's at 0, that puts B over at 3. We know that B is 7 seconds after T. So 7 seconds after, that's going to put T over here. And T is 6 seconds after D. So that puts D over here. And D is 4 seconds before A. And that's going to put A in between here. 2 more to go so that you've got plenty of examples to use for your homework. The 14 digits of a credit card are written in the boxes below. If the sum of any 3 consecutive digits is 21, what's the value of A all the way over here? So any 3 consecutive. So if I were you, I would start down here. If we need that sum to be 21, what does this box have to be? Go ahead and enter it. you should see that that needs to be a 5. And then we're going to keep working backwards. So then I've got 9, 5, and something. What would this need to be to get me to 21? I want you to keep working backwards, and I want you to go ahead and enter what you get for A. Last one. An island has no currency. It instead has the following exchange rate. 30 small fish is the same as 6 big fish. 30 big fish is the same as 3 nets. And 6 fishing nets is equal to 1 raft. So how many small fish equal a raft? And how many small fish equal 1 raft? Well, a raft is 6N, and I can work backwards from there. I can set up that I've got 30 small fish for 6 big, and I've got 30 big for 3 nets, and I've got 6 nets to 1 raft. And if you know anything about dimensional analysis, we see here that diagonally units cancel out. So the B's are gone, the N's are gone, and that's going to give me small fish to rafts. So you can multiply straight across. What do you get? And then I want you to multiply straight across in your denominator. What do you get? So how many small fish equal 1 raft? Nice job with this, guys. I'm hoping that this gives you enough examples to go off of to start doing the problems in MyLabs Plus. And if there's any that still cause you issues, bring them with you to class and we will go over them as part of the review. Have a great week.